All right, today we're pulling back the curtain on how the internet really works. We're going to dig into its fundamental blueprint, the OSI model. Let's dive right in. So, have you ever stopped to think about it? How does your phone, your laptop, and some server halfway across the planet all manage to speak the same language? I mean, how does data get from point A to B without just turning into digital gibberish? Well, the secret sauce, the magic behind it all, is a shared set of rules. Think of it like a universal translator for data, making sure every single device out there is on the same page, speaking the exact same digital language. And this framework, it's not just for computers. It gives a common language to everyone in IT. You know, from the person physically plugging in the cables all the way to the developer writing the software. It lets them all pinpoint exactly what's happening to our data as it zips across the network. Okay, so it's officially called the Open Systems Interconnection Model, but pretty much everyone just calls it the OSI model. Now, here's a really important point I want to make right away. The OSI model isn't actually what the internet runs on day to day. That's a different set of rules called TCP/IP. So you might be thinking, why are we even talking about it? Well, think of the OSI model as the perfect blueprint. It's the ideal map that helps us make sense of how the real-world stuff, like TCP/IP, actually works. So what does this blueprint actually look like? Well, the real genius of the OSI model is how it takes this incredibly complex process, sending data across the entire planet, and breaks it down into 7 separate, much easier to understand layers. And here they are. We've got layer 7 at the very top, that's the one closest to you, the user, all the way down to layer 1, which is the actual physical hardware. Now, to really get a feel for how data gets built and sent, we're going to start at the bottom and work our way up. Oh, and before we jump in, here's a super handy way to remember all the layers from top to bottom. All people seem to need data processing. That's application, presentation, session, transport, network, data link, and physical. It's a classic for a reason. It just works. Okay, let's do this. We're going to follow a single piece of data on its journey through this blueprint, and we're starting right at the foundation. First up, the absolute foundation of everything, layer 1. This is the physical layer, and it is exactly what it sounds like. We're talking about anything you can physically touch. The Ethernet cables plugged into your computer, the fiber optic lines buried underground, even the radio waves your Wi-Fi uses. This layer's only job is to turn digital bits into electrical signals, pulses of light, or radio waves, and just send them. That's why if a tech ever tells you there's a layer 1 problem, what they're really saying is, hey, go check if the cable is unplugged. All right, so our data is now officially a signal, flying down a wire or through the air. So what's next? Let's move up to layer 2 and see how we give that signal some local directions. This is the data link layer. People often call it the switching layer. Its whole purpose is to get data between 2 devices that are on the same local network. Think your laptop talking to your Wi-Fi router. And it does this using a unique hardware ID that's literally burned into every network card. That's called a MAC address, which is short for Media Access Control. Okay, but what happens when you need to talk to something that's not on your home network? Like, say, a web server on the other side of the country. Well, for a big trip like that, we've got to go up another level to layer 3. The network layer is all about routing. This is where routers live. They're basically the traffic cops of the internet. So while layer 2 was all about local chats using those permanent MAC addresses, layer 3 uses IP addresses to send our data on a global adventure, from your network all the way across the world to some other server. So let's make this super clear because it's a really important distinction. Layer 2 is for local communication, right? It uses those hardware MAC addresses and is handled by switches. But layer 3, that's for the big, long-distance conversations between totally different networks. It uses IP addresses and is handled by routers. Getting this difference is absolutely key to understanding how the whole internet is put together. Okay, so our router found a path across the internet. Awesome. But now we need to actually manage the conversation and make sure our data gets there in one piece. For that, we need layer 4. And this is the transport layer. You can pretty much think of it as the internet's post office. It takes big chunks of data from the layers above it and chops them up into smaller, more manageable pieces called segments. Its job is to make sure those pieces get delivered reliably. And the 2 big names you always hear about at this layer are TCP, which is super reliable, and UDP, which is way faster but doesn't double-check if everything arrived. All right, we are now at the top of the stack, the top 3 layers.
We often lump these together because they all work closely to get the data ready for the actual apps you and I use every day.
So first, layer 5 is the session layer. Just think of it as the conversation manager. It starts the conversation, keeps it going, and then ends it politely when everything's done. Simple. Then we have layer 6, the presentation layer. This is the network's translator. It makes sure data is in a format that the other computer can actually understand. This is also where really important stuff happens, like encryption with SSL/TLS to keep your data safe. And finally, we've made it to the top. Layer 7, the application layer. This is the one you actually see and interact with. It's your web browser, your email app. It's the part of the network that's right there on your screen. Okay, that's a lot of theory, I know. But how does this all look in the real world? What does it look like when a real piece of data is actually flying across your network? And here's where it all clicks into place. This is a snapshot from a tool called Wireshark, and it's looking at a real data packet. And check this out, it lines up perfectly with the OSI model. Down at the bottom, you can see the raw bytes on the wire. That's layer 1. Then you see the Ethernet info with the MAC addresses. That's layer 2. Right above it, the Internet Protocol with the IP addresses. That's layer 3. Then you've got TCP with the port numbers managing the delivery. Pure layer 4. And finally, at the top, you have the actual application data, all nicely encrypted. That's layers 5, 6, and 7, all bundled together. It's the whole model right there in one little packet. So, at the end of the day, why does any of this matter? I mean, it's a model from the 80s, right? What's the big takeaway here? It matters because the OSI model gives everyone a universal language for fixing things. When something breaks on a network, this is the playbook. An IT pro can ask, is it a layer 1 problem? Meaning, is the cable bad? Or is it a layer 3 routing issue? Or maybe it's all the way up at layer 7 with a bug in the app itself. By breaking the problem down by layer, they can find the root cause and fix it way, way faster. It is the ultimate troubleshooting cheat sheet. So there you have it. You now have the fundamental map of how the internet is built. And that's a powerful thing. It's a tool for understanding, a tool for fixing things, and maybe even a tool for building the next big thing. So the only real question left is, now that you've got the map, what are you going to build with it?